In this question, we're asked to find the magnitude of the electric field at the origin. So we have two source charges. We have a negative source charge of 7 nanocoulombs, which is 4 centimeters away from the origin on the x-axis. And we have a positive charge, which is 4 nanocoulombs, 2 centimeters away on the y-axis. On the right side here, we have our equation, which is just the Coulomb's constant times the charge over distance squared. All we have to do now is plug in our values. To get the x component, we're going to do Coulomb's constant times 7 times 10 to the negative 9th power over 0.04 squared. And that's going to give us our x component. And then now we have our Coulomb's constant times 4 times 10 to the negative 9th power over 0.02 squared. And that's going to give us our y component. So now that we have our x and y component, we're going to draw a triangle. We have our x component, which is going left because it's negative, and our y component pointing up since it's positive. We're going to try to find the hypotenuse of this triangle. But first, we're going to have to find the angle. So theta is going to be inverse tangent of 89900 over 39331.25. That's going to give us an angle of 66.37 degrees. We just have to go back to our triangle now that we have our angle and find the hypotenuse. That's going to give a sine of 66.37 equals 89900 over the hypotenuse. We do algebra to find our answer, which is 9.8 times 10 to the 4th power newtons over coulombs, and that is our magnitude. For our second question, we're asked to find the voltage at the origin. So we just have our equation here. The voltage is just Coulomb's constant times the first charge over the first distance plus Coulomb's constant times the second charge over the second distance. And this is just another variation of Coulomb's law. And we're just going to plug in our values. So we have the constant times negative 7 to the 10 to the negative 9th power over 0.04 meters. And then the constant times 4 times 10 to the negative 9th power over 0.02 meters. So that's going to give us two values here. We have a negative and a positive. We're going to add them together. It's going to give us a net negative voltage of 224.75. But since we're talking about the voltage just at the origin, direction doesn't matter. So we're going to have the absolute value of that, and we're going to round, and it's going to give us our answer of 225 volts.